Given a sample of n equals to 18 scores, how many of these scores would be involved in calculating the sample variance? Is it going to be just 2, 8, 15, or maybe all 18 are involved? All right, to do this, let's have a look at the formula itself. The sample variance is the sum of squares over n minus 1. That's my sample size, that little n there, sample size minus 1. Now right away, I can see that my sample size is involved, and the sample size n counts how many scores are involved. So already, in a way, we can see that all 18 scores are involved in finding the sample variance, because if I had one less score, I would only have 17, and that's going to change my result. Now that doesn't really pay any attention to the actual values of the scores, so let's have a look here at the sum of squares. I'm drawing two arrows for sum of squares because there's actually two different formulas for the sum of squares. I've got what's called the definitional formula, and I've also got the computational. They both give you the exact same result, but they go about getting to it in a different way. The definitional formula is the sum of your squared deviations from the mean. So inside of the brackets, this is a deviation. When I square them, it's a squared deviation, and finally there's a summation sign here. The computational formula is the sum of x squared minus the sum of x itself squared over n. So once again, it doesn't matter which one of these formulas you use, they're both going to give the same result. I'll do an example in a moment where I show both of them doing that. However, I do want to point out one thing here. Each one of these formulas has the summation sign involved. In fact, this one's got it twice. Anytime you see a summation sign, what it means is that you're going to be performing the same operation again and again and again, and then adding up the results of those operations. You're going to perform the same operation on every single one of the scores involved in your sample, or if we were doing a population, in your population. So in other words, whenever you see a summation sign, you're going to be involving every individual score, all 18 scores. So the answer is going to be all 18. But let me give you a quick example here. I'm just going to make this fairly simple. Let's say I've got 1, 3, and 5. These are my three values. Let's see, what does this add up to? That's going to add up to 9. Okay, that'll make it nice and easy. Okay, so I've got three different values here. Now, if I want to find my sum of squares, let's start off with the definitional formula. The definitional formula says that I'm going to need to know my sample mean. And so to find my sample mean, the sample mean being the sum of x over n, I need to know my sum of x. And that is 1 plus 3 makes 4 plus 5 makes 9. So this is 9 over 3. My sample mean is 3. Now the order of operations, which I cover in the appendix chapter, the order of operations says I have to do brackets first. So I'm going to have a look at just what's inside of the brackets. I'm not going to think about anything else. I'm not going to worry about the squared sign or the summation sign. And what I'm going to do here is I'm going to take each x value and subtract 3, which is the mean. So 1 minus 3, that's negative 2. 3 minus 3, that's 0. 5 minus 3, that's 2. So now I've done my first part of the order of operations. In the appendix chapter, I show that brackets are the first part. We've also dealt with subtraction. Because that was in the brackets, normally I would do it last, but because it was in the brackets, it happens first. So that's dealt with. Now I look at exponents. So now I have to square my results. So 2 squared, negative 2 squared is 4. 0 squared is 0. 2 squared is also 4. And so that's taken care of. In this formula up here, I don't have any division or multiplication, but I do have addition. That is when I sum up my values, and I get the sum of x minus the mean squared. So this is 4 plus 0 plus 4, that's 8. So my sum of squares is 8. Now I can also do this using the computational formula. So in order to do that, let's keep track of the fact that this was 8 here. I'm going to make a bit of space and then go back and work out my squared x values. So because we've already got the sum of x, so we've already got this part, we know that n is 18, I just need the sum of x squared. And my order of operations, let's clean this up once again. Brackets, exponents, division, then multiplication, then addition, finally subtraction. I don't have any brackets going on here, but I do have exponents. I have to think about the exponent part first before I eventually get down to addition. So when I'm looking at working out the sum of x squared, I have to just do the x squared part first. So each one of these gets squared. So 1 squared is 1, 3 squared is 9, 5 squared is 25. This is 10, 25, this is 35. So that is the sum of x squared is 35. So my sum of squares is the sum of x squared, that's 35, minus, in brackets, the sum of x, that's 9. I've got to square that, and then divide by 18. Now 9 squared is going to give me how much? 9 squared is 81. 81 divided by 18 is 4.5. So that gives me 35 minus 4.5, and that is not going to give me the right answer. So something is up here. Let's see. 5 squared, 3 squared, 1 squared, okay. 9. 81 divided by 18. Oh, because I'm dividing by 18. This isn't divided by 18. My example only has 3 scores. So it's going to be 81 divided by 3. That's better. That's 27. Okay, so 35 minus 27. This gives me the right answer. That's 8. Okay, so I was getting a little bit confused there because I was thinking n equals to 18, when in fact I've only got n is 3 scores in my example, so n equals to 3. I didn't want to do an example with 18 scores because that would have taken forever. Okay, so you can see that no matter what, sum of squares is equals to 8. Doesn't matter which formula I use. And each of the formulas made use of every single one of the numbers. So if I had 18 numbers, if I had 18 scores, I would use all 18 of the scores in order to find the variance, which is how I find, in order to find the sum of squares, which is how I find my variance.